Okay, guys, I'm out again. Um, so let's record this video, and you guys can take some notes on it. Okay. All right. So 7.6 is apply sine and cosine ratios in our text, in our curriculum, I should say. It is 2.7. Okay. So yesterday we talked about tangent. Today we're talking about sine and cosine. Okay. All right. So go ahead, sketch yourself a right triangle. Okay, I'm going to go ahead and use A, B, and C. Okay, I'm going to go ahead and use the 3, 4, 5 right triangle again, just because it's easier to use than like a bunch of letters all the time. Okay, so remember, let's write that out. So that silly mnemonic. So ka toa. Okay, remember that this so is for sine. This is for cosine. And this is for tangent. Yesterday we learned about tangent. Today we're going to learn about sine and cosine. So tangent was the ratio of the opposite over the adjacent. So sine is going to be the ratio of the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. That's why we memorized that silly mnemonic. Okay. This is go through it. Not making it any more complicated than it has to be. So these are functions, right? So we're going to abbreviate it with SIN, but please read that as sine. It's not sin. So let's look at A. Okay, so let's look from the angle A. In relation to angle A, what is the opposite side? It is 3. Okay, in relation to angle A, what is the adjacent side? It's 4. Okay, in relation to angle A, what is the hypotenuse? Of course, it is 5, and it will always be the the side opposite the 90-degree angle. Okay, so sine of A, sine. So sine will be the ratio of the opposite over the hypotenuse, right? So what is the ratio of the opposite over the hypotenuse? That would be 3 over 4, right? So sine of A is equal to 3/4. Okay, let's figure out what cosine of A would be. Remember cosine, so toa, cosine is the ratio of the adjacent to the hypotenuse. And I just realized that I messed up. Hopefully you did too. I want the ratio of the opposite to the hypotenuse. What did I put down here? 3/4. What's 4? 4 is the adjacent side, so I shouldn't have put 4, right? I should have put 5. Sorry, guys. I don't know if you have much experience with like pain, but if there's like a background pain, it's amazing like how quickly you observe a cognitive decline. I'm like walking into walls. I can't function almost at all. But I'm trying my best here. It's bound to be some more mistakes happening. Okay, so the ratio cosine of A is the ratio of the adjacent to the hypotenuse. So what's adjacent to A? It is 4. Right, the hypotenuse is still 5. So the cosine of A is equal to 4/5. All right, so far so good. Talking to you as if you're there. All right. So let's do the same thing, but now let's do it in relation to not angle A, but to angle C. Okay, I'll do that in blue. I don't know if you can tell that's in blue. So in relation to angle C, is 4 still the adjacent side? No, right? 4 is now the opposite side. Okay, what about 3? Is 3 still the opposite side? Well, clearly not, right? 3 is now going to be the adjacent side. And of course, the hypotenuse remains the hypotenuse. Okay, so let's do sine of C. Right, so ka toa is the ratio of the opposite. Let me do that in blue. Ratio of the opposite over the hypotenuse. Up, I froze. I don't know why it does that. I'll never figure it out. It seems like when I do that, my face freezes too. Ugh. Get that out of there. All right. So it's the ratio of the opposite of the hypotenuse. So looking from C, what is the opposite side? Well, we already labeled it. That was nice of us to do. So the opposite side is 4, right? What's the hypotenuse? Hypotenuse is 5. Okay, so sine of C is 4/5. The same thing as cosine of A, which is kind of interesting. Okay, so then we'll do cosine of C. So ka toa, that's adjacent over hypotenuse. All right, so cosine of C, what's the adjacent side of C? That's 3. And the hypotenuse is still 5. So cosine of C is 3/5. I find it easiest to just learn through examples, right? These are just examples. I find it easiest to learn through examples. Okay, all right. So that is essentially what sine and cosine are. Make sure you add the title to your notes here. Okay, that was 2.7, 7.6. Sine and cosine ratios. All right. So what does a textbook? How would the textbook have presented this to you? Turn the page. So this is what they say. Let's just read through it. Don't feel like you have to copy everything down. I thought that it was a little bit much. I kind of like how I laid it out slightly better. But let's go through it. So the sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of a leg and the hypotenuse of a right triangle, right? That leg we determined to either be the adjacent or the opposite side, depending on what angle we're looking at. Okay, so let triangle ABC be a right triangle with acute angle A. Okay, the sine of A and cosine of A are defined as follows. So, yeah, we already talked about this. This is essentially what you need to remember right there. Remember, SOHCAHTOA. SOHCAHTOA, sound it out. All right, let's do some examples here. Find sine of S and sine of R. Write each answer as a fraction and as a rounded decimal to 4 places. All right, fine. So let's look at S. Sine of S. Remember, sine is so. Remember, you should probably just write it every time. So, ka, toa. Okay. So sine's ratio of the opposite to the hypotenuse, right? So let's look at S. What's opposite S? 63. Okay. What's the hypotenuse in relation to angle S? Well, the hypotenuse is always the hypotenuse, the side opposite the 90-degree angle. So that's 65. Okay, there is our fraction, and they want it as a decimal rounded to 4 places. Do I have a calculator open? No, of course I don't. It'll take 10 minutes for it to open, but whatever. Let's get sine of R while we're waiting. Sine of R. So it's still opposite over hypotenuse, right? But now we're looking at a different angle, R. Oops, sorry. So in relation to R, what's the opposite side now? Well, it's not 63, right? That'd be the adjacent side. 16 is the opposite side. What's the hypotenuse? 65, as it was before. So let's see what those decimals are. We have 63 over 65. 0.9692. Okay. Yep, that rounds right. And then we have 16 over 65. 0.2462. Okay. So those are our two answers there. All right. So sine is so, cosine is ka. Okay, we need to find cosine of u, cosine of w. So cosine of u. So u is here, cosine, so ka toa, that's adjacent over hypotenuse. What's adjacent to angle u? It is 18. Okay, what's the hypotenuse to angle u? Well, the hypotenuse is, make sure that that's an h, okay? Hypotenuse is always opposite 90-degree angle, so the hypotenuse is 30. Okay, let's figure out that is 18 over 30. 0.6. All right, that's nice. All right, guys, I want you to try to figure out what cosine of w is. So pause the video and then figure out what cosine of w is. And see how then you can compare it to what I have. All right, so cosine of w. Where's w? W is right here. Okay, so cosine adjacent over hypotenuse, right? Still adjacent over hypotenuse. The more you write, the more you will remember. So what's adjacent to w? 24 is. And the hypotenuse is still 30. So 24 over 30. 0.8. Okay, hope you guys are doing good with this. Just the more examples we have, the better you're going to understand it. All right. So you know how they like to do? They like to just throw in a little bit of context to try to confuse you, and miraculously, it does sometimes. But all you have here is a triangle. It just happens to be, imposed on the blueprint of a house. Looks like. So we have an 11, an X, and a 35. Okay. You want to string a cable to make a dog run from the two corners of a building as shown in the diagram, right? And solve a proportion using a trigonometric ratio to approximate the length of cable you will need. Okay, well, they gave me 35 degrees. So I'm just going to go ahead and use that. Why make more trouble for myself? So in relation to 35 degrees, what is 11? What is x? Well, it's pretty clear this is a right angle. So x has to be the hypotenuse. Okay. 11 is going to be what? The adjacent or the opposite side? Think about it. Going all the way across the triangle, it doesn't involve either one of my sides of my angle. So this has to be the opposite side. Okay, so write out your trig ratios, or that's silly mnemonics. So ka, toa, right? Which one of these uses the opposite and the hypotenuse? Opposite and hypotenuse. Which one of these uses the opposite and the hypotenuse? Well, it's this one, right? That will be sine. So we're going to go ahead and use that. Set it up. The sine, remember the input for a trig function, unless it's an inverse trig function, is always a degree. So we're putting sine of 35 degrees is equal to the ratio of the opposite side to the hypotenuse. Opposite here is, well, let's write it out. Okay, so sine of 35 is equal to the opposite side over the hypotenuse. Now we have to just solve for x. Okay, let's multiply both sides by x. By the way, if you do this a couple times, you'll see what ends up happening, and maybe I'll show that to you. So multiply both sides by x. These cancel. Now I have x times sine of 35 equals 11. Now I want to solve for x, so let's get rid of that sine of 35. Okay, so these will cancel as is desired, and x is equal to whatever this is inside of a calculator, 11 divided by sine of 35 degrees. Okay, now notice what happened in between that first step, right, sine of 35 equals 11 over x, and this last step. Well, sine of 35 and x just swapped places, right? They just swapped places. So that's something you can do. Don't try and take shortcuts until you know the way. Otherwise, you will get lost. All right. But once you do this a couple times, your algebra skills, your intuition will lead you, right? All right. So what is 11 over sine of 35? $18.17. So I'd probably just go ahead and say, so it's 19.18. This is in feet. So I'd go ahead and say approximately 19 and a half feet. I might even go out there and buy 20 feet of cable. You gotta make nuts and stuff, Okay, let's keep going. All right, so a lot of times I like to involve some context with these problems, and they're not hard, but there's a couple things you have to be aware of. They sound like really confusing, but they're not. So one of those things is angle of elevation. The other is angle of depression. So when you elevate, you look up, right? When you're like climbing up a mountain, you're looking at an elevation, so you're looking up. And when you're depressed, people look down a lot. So it's an easy way to remember: depression down, elevation up. So if you look at an object, the angle of your line of sight makes with a horizontal line is called the angle of elevation. So this angle here, so we are always referencing what's called the horizontal. Okay, so this difference between the horizontal and my angle of sight is called an angle of elevation. Okay, now this person's standing a little bit above me on this like wee bit of cliff here. So if you look down at an object, the angle your line of sight makes with a horizontal line is called the angle of depression. So the difference between this horizontal and that line of sight is an angle of depression. Depression down, elevation up. Okay, we're always referencing a horizontal from the line of sight. Okay, you should have that put in your notes. Let's go ahead and look at an example with it. So you are skiing on a mountain with an altitude of 1,200 feet. Certainly not around here. Well, maybe. Actually, we got some around 1,200 feet. The angle of depression is 21 degrees. How far do you ski down the mountain? So normally you'd have to generate this diagram. They're nice enough to give it to us here. So the angle of depression is 21 degrees. So this is my horizontal and this is my line of sight. So this angle here is the 21 degrees. That's the angle of depression. How far do you ski down the mountain? So hopefully you can see that what we've got going on here is essentially a rectangle that I've cut in half with my line of sight. Okay, so we are looking for the hypotenuse in a right triangle. That triangle is here. So be able to ignore, the noise. Okay, a lot of noise going on there, but this is what we're interested in. All right, so what trig function am I going to use? Let's write it out. So, ka, toa. Try and guess. What trig function will I use? I'm given 1,200. I'm looking for x. Pause it and take a guess. Well, in relation to 21 degrees, what is 1,200? It's the opposite side. In relation 21, well, it doesn't matter, right? X, since it is opposite 90 degrees, will always be the hypotenuse. Okay? So, what uses the opposite in hypotenuse? Sine. So, sine of 21 degrees is equal to opposite over hypotenuse. In this case, that's going to be 1200 over x. Okay, try and work this out on your own. Pause it, try and work it out, and then compare with what we have. So again, multiply both sides by x. I'm going to do it in 2 steps now. Well, I should probably just keep doing all the work. I don't want to start taking shortcuts that confuse people. Okay, then I have x times 21. X times sine of 21 is equal to 1200. Divided by sine of 21. And x will equal whatever that is inside of calculator. 1200 divided by sine of 21. Oops. It's like so slow it won't take my keystroke. 1200 divided by sine 21. 3,348.5 feet. So like 3,350 feet. Okay. What else do they have for me? Oh, that was it. So now they just want me to reiterate some things. Remember, sine is the ratio of the opposites of the hypotenuse. Cosine is the ratio of the adjacent over the hypotenuse. Remember, SOHCAHTOA. Also, remember your angle of elevation and your angle of depression. Okay, we'll get plenty of practice with this coming up. You can now start that IXL with the trig ratios. Try and get that IXL up to a 70. I realize that you guys don't work well with no due dates with the IXLs. You have to learn how to manage your own time. Right? I give you plenty of time, like a week to do it. Right? That doesn't mean that you never do it. Okay, so figure out your own due dates for the IXLs. A lot of you guys, aren't doing them, and you're not getting the practice, and then you're failing the quizzes and the tests, and you're like, well, I don't know what's going on. And I've said it before: if you do nothing but put, garbage and poop into a milkshake, you can't be mad when it tastes like crap. Okay. All right. I'll talk to you guys tomorrow. Hopefully, I'll be able to stand most of the day. I'm already hurting pretty bad, so I'm gonna go lay down. Have a great day. Be safe. Turn in these notes for me. Okay. How do I turn this thing off here? There we go.